Hello, programming languages students. Welcome back for another Prolog list example. So today, or I guess in this video, we'll be talking about the a2b predicate. So the idea behind this predicate is that we want to check if, for two things. One, that two lists are the same length, and two, that the first list contains only A's and the second list contains only B's. So we need two equal length lists, one of all A's and one of all B's. So this should return true, this example here. This one should return false. 3A's and 4B's should be false. And, something like this should also be false. We have two lists, they're the same length, but one has a T in it, one has a C in it. So this doesn't work. Even this should return false, right? So 3A's and a T versus 4B's. This is not a list of all A's, that's the same length as a list of all B's. So this should return false as well. So specifically, 3A's, 3B's would be true, 4A's, 4B's would be true, but it's pretty restrictive. And so um, when we're dealing with this type of problem, or again, really any list problem, you want to start with what is the simplest case? What is the easiest way for me to really directly and easily check whether we have two lists that are the same length and don't contain anything other than A and B? So the solution to that, there's two really kind of base cases you could really check. The first one that kind of makes sense is this. If we have two lists, one is A and one is 1B, then that works. And it depends on this again depends on how you interpret the problem. But you could also say that two empty lists would work. And this really depends on it, either way you write the predicate here, the very first base case, it will work. It just depends on whether you personally decide that a2b should include empty list as an equal comparison. So I'm going to start with empty list as an option. And I'll show you what happens if we switch this to only B. You have to have at least one A and at least one B. So it depends on whether you want 0 or more A's or 0 or more B's, or 1 or more A's, 1 or more B's. But however you define it is fine, unless of course it's specified. In this case, I didn't really make it clear, so your choice. But this base case or this base case makes sense. So these are the two easiest lists to compare and verify that they're correct. So for the second part, we need to think recursively. So we're going to take an a2b list. Now, how might we approach this? Let's see here. What if we took, so we've talked about, and by the way, if you want to pause the video and think about it yourself, please feel free. It would be really good practice and thought process here. So if you want to pause the video, please do. But what we really want to do, if we're comparing these two lists and we want to make sure they're both, the first one's all A's, the second one's all B's, and they're the same length, ways we can do that. And again, when we're working with lists, first thought, how can I split this into a head and a tail to solve a problem? Just like in Java or Prolog or Java or Python, how can I write a loop to go through this list to solve a problem? So the first thing is, so we want to split it into a head and a tail. And specifically, if we want to verify that the first list is all A's, then the head has to be an A, right? If we ever split this into a head and a tail and don't get an A, that's a problem. We should have false and this should not work. So the head should be A, and then the tail we'll call L1 or list 1. We could call it T1 as well, tail 1. That's fine. So let's use T1, tail 1. And then the second list similarly would be B and tail 2. So within our predicate, we're going to split these into a head and a tail. And we're putting specific requirements on the heads of our lists. The head of our first list must be an A, the head of our second one must be a B. And then recursively, all we have to do is pass in tail 1 and tail 2 to do another iteration. So wait a second, you say. I can see how this is checking for A's and B's, but how is this checking for the same length? Well, if we look at this recursively, and we're splitting these into an A and a B, every iteration we must either have an A and a B and a tail for each list, or the lists have to be empty. So what happens if one list runs out first? Well, let's say the A list is shorter. As we recursively go through, so let's say the A list was 2 elements, the B list was 3. Before I run this, let's recursively run through this example. If we have an A list with 2 and a B list with 3, the first iteration, this is not true. They're not empty. They're not both empty. The second case here, we have A and A as a list. That's our first pair that we bring in. And then our second one is going to be B and BB as a list. And so we're going to run another iteration, and I guess I should comment this out. We're going to run another iteration where we pass in the tails of each list. So we pass in A and BB as the list we run our next iteration on. And so, and I guess if we really wanted to make this clear, let's do this. We started with a list AA and BBB, and that split like this. Now we take the list A and the list BB, and we're gonna split them. And so the head is going to be A, the tail is going to be an empty list, and on the other side, the head is going to be B, the tail is going to be a list with just B in it. All right, so we're splitting these two lists. So we check the first check here. Do we have 2 empty lists? The answer is no. Is this predicate okay? Well, so far, yes, right? The head is A, the head is B, so this checks out, which means we run one more iteration. And in this case, we're going to start the iteration with empty list, right? The tail of this A list is empty, and a list with just B. So first iteration, second iteration, third iteration. Well, this is false, right? It's not 2 empty lists. And this is going to be false, because we cannot split this list into a head and a tail. So now we have 2 false predicates, and so these 2 lists of different lengths only evaluate to be false. We can't enter this recursive loop if this check is not possible, if this condition is not possible. And this condition requires us to be able to split both lists, and we can't. So this now ends. And so this actually, these 2 predicates check for the 2 lists have to be the same length, because at some point they both have to be empty at the same time. And they both must always be only A's and B's, because this predicate requires an A at the head and a B at the head to be able to continue iterating until the list is empty. And so we'll see that this works. So AABBB does not work. AAABB gives us true. Too many A's and too few B's gives us false. A list with anything other than B's in it also gives us false. A list with anything other than A's in it gives us false. So this actually turns out to be a pretty simple predicate once you get into it. But it works with any size list of A's and B's, and it verifies that they have to be A and B. So hopefully this makes sense. This is another good example of a recursive function here that lets us, a recursive predicate, that lets us look at 2 lists, and in this case verify that the first list is the same length as the second, and the first list contains only A's, the second contains only B's. So this is another really good base example when you're trying to compare 2 lists that's very helpful for a lot of different applications. If you make a few little tweaks to this, it'll show up fairly frequently when you're working with lists. Hopefully that makes sense. Please let me know if you have questions. See you next time.